Hello everyone and welcome to the demonstration video. So in this video we're actually going to be going over what we call control statements. So this is going to be what you've probably heard of about branching statements, loops. We'll discuss exactly what those are. Alright, so to begin, let me at least first show you guys what that looks like. So remember when you did your pseudocode, so your pseudocode and flowcharts, we went over 3 different structures for algorithms. You have sequential, conditional, and looping. As you saw with sequential, it was very straightforward. So let me go ahead. I'm going to do an S for sequential here. And there you would have some single instruction and it would lead to the next. So if you did it for pseudocode, like you wrote out the instructions, it was very simple. You'd go 1, 2, 3, 4. And you go on all the way till the end until maybe you have, until you get to whatever your result is. So I'll do the results as something that's red. Let me undo this. There we go. Okay, so that's sequential. Let's do a divider line just so we could tell the difference. There we go. So again, sequential is just one after another. Nothing too fancy about it, and this is just a single controller flow. So when we do instructions with coding, it goes in order. So in this case it goes 1 instruction, 2, 3, and then whatever the output is or the final instruction. Now you also had conditional, so I'll mark that with the C, which gets a little bit trickier. So you could imagine this as like a river flowing through. And when it comes to conditional, so let's say we have a statement, right? And it goes normally, maybe we have another instruction. And as some of you saw with the flow control, you'll get something like this. So we typically indicate a branching path with a triangle, and within this, not a triangle, but a diamond. And here you'll notice that this was a yes or no question. So it was a question that is asking the user, or even in some cases the algorithm itself, whether it's yes or no. And based on the answer, it splits off. So it's a conditional statement. You choose whichever place you're going to. So in this case, this one is yes, and this one's no, based on the condition that this is asking. Like in this cases of some of your sandwiches, it's, do you want peanut butter? If yes, then you'll go to this instruction to add the peanut butter. And if no, you go to this instruction, which maybe puts on another topping. In some other cases, maybe it just skips over the peanut butter step. So branching statements will have these 2 choices as compared to sequential. It goes one after another. Here it'll check if something, it'll check for a condition, some kind of yes or no statement. And depending on the answer, it'll go to a different instruction. And in some cases it could lead back. So let's say it leads back to another instruction, and then it ends with an output. Sometimes based on yes or no, so this is still going to be conditional. So let's say we have an instruction here, another instruction, and then maybe we have that conditional, so that branching statement. So sometimes, maybe as I mentioned, it'll do one thing if yes, and then go back into the flow. And other times if it's no, maybe it'll just skip that step all over. So it can look like this. I'm even going to add on to this, and sometimes maybe let's say this comes to a conditional. So there we go, our question mark. Sorry, I'm working with the space here. That's a question mark. And you could probably have even 2 different outputs based on what's going on. So either one or the other, and then it stops. And as you can see, you could create bigger trees with something like this. So that was the conditional control of flow. and you'll see it's a branching path, but notice it always still streams down to the end. So you could think of it as a river. Here it's being split, whether that's some kind of divide by a mountain or a tree or whatever it's going to be. And then it'll somehow rejoin, or in this case it goes down and it splits off indefinitely. So that's your conditional control of flow. These is what we use for something called if-else statements. So you'll hear me talk about if statements, if-else statements, if-else if statements, and just know that that will be your conditional control of flow. Now I'm going to go ahead and erase all this. There we go. And one of the structures that some people got a little confused with, but I believe it'll be a little more easier to visualize with this diagram and coding it in, is your looping. Oh, that's still the eraser. There we go. Let me make that wider. Okay. So looping, I'll just put an L for it. So think of it, again, we have our instruction here, and I'm actually going to leave going to use some space. You go on to another instruction here, and you'll come across some kind of, again, yes or no question, so some kind of condition that needs to be met, and depending on yes or no, kind of works as the conditional. It'll branch off based on that answer. But instead here, maybe yes means, so this is yes, so this is yes, and maybe that means go to the next instruction. There we go. Other times, like in this case we have an instruction for no, instead of branching off to another instruction, it's actually going to have you go back. So it's going to go back to previous instruction or a previous point in your algorithm and then continue. So you could think of this as some kind of weird river that's going to flow back on itself. Or in this case, you could just think of it as a street. Maybe someone missed an exit or missed their turn, so they could go in and loop around and come back here. Okay, so a lot of this happens in different ways, and you could actually combine looping with conditional. Like let's say here, so we come across another yes or no question, and maybe you got something where it's like yes will branch off here, no branches off here, and maybe this has its own set of instructions. There we go. And it'll ask like a yes or no, and based on that it'll maybe loop over here, and notice, there we go, this is where we got a lot more functionality going. Actually, let's make that one at the end of the algorithms. There we go. So just as long as you have some kind of arrow pointing back to an existing instruction, that would be looping. And actually what I wanted to show here is, okay, let's do this. If I could erase it more, there we go. So sometimes instructions can loop on themselves. Sometimes you'll see that case where, oh, not with red, where if it's no, or whatever the condition is, it'll just loop in on itself and repeat over and over again until yes is met, and then it'll go through. So just as, again, as long as you have some kind of arrow pointing, some way to go back, go against the flow of the algorithm, that will be looping. So we'll be taking a look at a couple of those structures, and actually some looping structures for Java, or in programming in general. You got something called for loops, and then you have while loops. So each allows you to create this looping structure. However, they're going to have different ways to implement that. So let's go ahead and take a look here. So let's start out with the branching. So our conditional flow structure, remember that was with if, else statements. Okay, there we go. And I say if else statements, but it does generalize to you got if statements. There we go. So just normal if statements, and here's how it works. So I'm going to just set up the normal structure. So typically to start this off, and remember you still have to write within your main method to get any of this going. I'm going to type in if, do parentheses, and then put in my braces. Again, for my, for Eclipse, it automatically puts the end braces, but make sure you have those two braces to indicate the code within here. Okay, so this structure is basically what's going to happen is, so it's saying if some kind of condition is met. So again, that's a yes or no statement. In this case, let me actually hold a variable up here. So I'm going to call this int a, and this equals 5. So over here, I'm going to check if a equals 5. So we're going to say a and 2 equal signs equals 5. So this is what we call conditional operators. Basically, instead of doing some kind of math like 1 plus 2 or 1 minus 2, this says, does a equal 5? Then based on that, it'll return the value of true or false. So let me go ahead up here. So conditionals work in logic, and they always return as true or false. So if this statement is true, so if a equals 5, it'll return true. If not, it'll return false. So in this case, it returns true. So in the case of the if statement, anything that's within these parentheses that comes out as true will execute whatever is inside the braces. So if true, then do this. If not, ignore it completely. So let me actually, the best way to go about learning how if else statements works is printing stuff out. So actually, I'm going to go ahead, down here it's going to be, this is the end of the algorithm. This is the end, this is the start. And now here, if it prints it, I'm going to say the variable a is equal to 5. So now if I run it, this comes out as true, so this will print. So let's go ahead and run. There we go. This is the start of the program. The variable a is equal to 5, and then it ends the program. Now watch what happens if I set a to 4. There we go. So you see it just says this is the start of the program and this is the end of the program, but it doesn't print this out. Again, that's because 4 does not equal 5, so this came out as false. So this will print out the variable a is equal to 5. Now if I get this if statement, so let me just replicate this and say a is equal to 4. There we go, and change this output to 4. So now you'll see there's different branching statements where I'm saying, hey, if a equals 5, print this out. If a equals 4, print this out. So let's run this. There we go. So this is the start of the program. The variable a is equal to 4. So you notice it completely skips this instruction because this is not true. 4 does not equal 5. But here 4 does equal 4, so this comes out as true, and it'll execute this statement. So again, remember, whatever comes out as true within these parentheses, this statement will execute this part. Now, if you wanted to where you say the variable is equal to 5, or actually in this case, let's say the variable is less than. So this is another conditional operator that you could use. A is less than 5. So we could say the variable a is less than 5. And if we want to say is greater than 5, some people may do this. So they think, okay, if a is less than 5, then it'll print this. If a is not less than 5, so maybe it's greater than or equal to, then it'll print this. But watch what happens when we run this. And there we go. So you see start a program, but it prints out both statements. So since 4 is less than 5, that's true. So print out the variable is less than 5. But it's still going to execute these. So it's not going to stop this from not printing. It's going to still go ahead and say the variable a is greater than 5. So if you have something like this where you want one or the other, there is a way to go about it. So let me go ahead and put some space. And along with your if statement, there's something called an if-else. So let me actually go ahead. Here, let's restructure this. So let me cut this. So this is an if statement. Let me comment this out. And I'm just going to get that portion. And down here is what we're going to call an if-else statement. There we go. So adding on to this if statement structure, you could, right after it, so right after its braces, you could say else, and then do another braces. Remember to have the pair. And now here, I could get this part. So I wanted one or the other to print. So I'm going to go ahead and there we go. I put that statement in here, and what this is going to do is if this condition is true, so if a is less than 5, then the first set of braces will print. So any instruction within here will print. So in this case, it'll say the variable a is less than 5. If it's false, it'll go ahead and do whatever is within the else. So in this case, it'll print out system out print line, the variable a is greater than 5. So now if we run it, only one or the other will execute. There we go. So this is the start of the program. The variable a is less than 5. So 4 is less than 5, then that prints out. If I say a is 10, let's run it. And now it says the variable a is greater than 5. So since 10 is not less than 5, 10 is greater than 5, this will turn out as false, and it'll go ahead and execute whatever's in here. So you do have to be careful of what different kinds of branches you want. Like if I delete, let me erase this. Let's show a visual representation in a flowchart. And this is why I wanted you guys to practice flowcharts, at least initially, so you know kind of how to start planning your algorithm. So at least with this, here, let's take a look at how this is working. So this if-else, this is basically, you could think of it as, so we have our instruction where we say a in this case is 10. Then we go on to our conditional that asks, is a less than 5? So if true, then it prints, can't really write it in, but print less than. There we go. Kind of hard to see, but I hope you could kind of understand it. If false, then print. So this is false. Oh, let me write that in. There we go. Then print greater than. And then it still just leads back to printing out the end of program. So print end. So this was the if-else structure. Whereas our if structure, there we go. So same thing, you start out with, here we got a equals 10. So that's one instruction. Then we checked if a is less than 5. And in this case, we only had one. So if it was true, you would print. So print less than. Sorry, my writing is getting atrociously worse. Less than. And then you go back to the print end. But if it was false, it would just go straight to the print end. So notice that's how the if else versus if works. In the case of if you don't have some kind of else, it's just going to go ahead and skip if it's not true. While here, if you want something to print specifically for if it's false, you'd have to do the if else. So that's how you would see it, the difference between these two. Now there is a little more something you could do. So notice if I set this right to 5, okay, so a is equal to 5. So let's see what it says when 5 is less than 5. There we go. So you'll notice it says the variable a is greater than 5, which isn't necessarily true. 5 is equal to 5, so maybe we want that to show. So there is something called here. So I'm going to comment this out again. I'm just going to take this chunk of code and copy it. Let me comment this out. There we go. And there is something called an if else if statement. So again, I'm just going to get that piece of code up here. So we're still working with our a is less than 5. But in this case, if we want to do an if else if, in your else, so right in between your else and your brace, you'll type in if and do your parentheses. And now you could put in a new condition to do for this part. There we go. Well, so let's actually do a is greater than 5, and it'll print out accordingly system.out.println, the variable a is greater than 5. So if I run this, you'll notice it doesn't actually do anything because we have kind of this if statement attached. So if you say else if, what's going to happen is, remember, we're still going in order. So we have a is equal to 5. So it's going to check this condition first. So is 5 less than 5? No. So it's false. It's going to skip over. Then it's going to check this. So else if, okay, so let's check this. If a is greater than 5, in this case 5 is actually not greater than 5, so it's going to skip over this. That's why we have nothing printed out between the start and the end. So you could actually add on to this chain. So if you want to print out saying a is equal to 5, just put in your else. You don't even have to put in condition, because the only other way for a number to be not less than or not greater than is to be equal. So now let's just go ahead and have this print out. The variable a is equal to 5. So now if I run it, there we go, the variable a is equal to 5. And if I change this to 6, let's run, the variable a is greater than 5. So you notice, so 6 is not less than 5, so this comes out as false, so we skip over. 6 is greater than 5, so it'll print out whatever's in here, and then skip everything else. So that's the beauty of if else if statements, if else statements. So just keep that in mind when you're looking at this. In the case of these if else statements, you could kind of think of it as, here, let's do a quick drawing. Okay, so this is going to be if else if, and remember we start out with our a is equal to some number. I'm just going to put a question mark for now. And then we're going to check, is a less than 5? And if false, then you could see it as going to another conditional. Okay, is a greater than 5? And if false, then it'll print out. So if it's neither of these, then the only option is that it has to be equal. So we'll just say print, and I'll actually put the sign here. So print equal. There we go. And now if it's true, these will just respectfully go to their own statement. So in this case, if this is true, then you'll print that it's less than. And again, I'm just using the symbols for the sake of writing. There we go. So if that's true, and if this is true, there we go. That would print that it's greater than. So print greater than. And I notice it all just come back to the end. So I'm just going to type here end. So that's kind of what we're doing with if, else, if. You'll notice that it goes straight to another condition that it's asking and doing whatever instructions based on that path. Okay, so do keep that in mind. You could keep on extending to this else if you want to check for, like if you want to check to see if it's maybe greater than 10, equal to 10, all you have to do is add the if statement in here and then change whatever instructions you want within the braces. And do note, it's not just this one single statement that you could do. Maybe you want to print out multiple things. Like in this case, maybe if it's greater than, you want to print meow, you can. So right now it should be, yeah. So if I run this, there we go, greater than, you could say meow. And you can even do if statements within these. Just make sure you have this indent. It's not necessary syntax wise, but it is easy for you to see. So you'll know that if this is true, then anything here, so within these braces, with it at this indentation level, is what's going to be performed. So again, you could put else if statements within that. All right, so let me go ahead and comment this out. So those are different branching statements. Now let's talk about our looping statements. More specifically, let's start out with just the while loop itself. Okay, so when we're talking about looping statements, they kind of work like if statements. So in this case with while loops, you're actually going to start out with the word while. We're going to do a parentheses and braces again. There we go. So again, just like with if statements, we're going to put a conditional within our parentheses. So some kind of yes or no question that we're asking up here. Now, if it's true, it's going to go ahead and execute whatever's in the braces. So again, looks very much like conditionals. But instead of moving on, it's going to check back. It's going to jump back to where it says while and then check that condition again. And it'll keep on repeating on and on. So actually the simplest way to look at this, I'm going to go ahead and create a new variable. So I'm going to call this int count. And I'm going to set this to 10. There we go. And I'm going to say count needs to be greater than 0. So as long as count is greater than 0, it's going to repeat, it's going to keep on printing out. Let's keep it to meow. There we go. Now, if I run this right now, it's actually going to go on infinitely because 10 is always going to be greater than 0, so we're going to have a whole bunch of meows. So I'm not going to run this just yet. What I'm actually going to do is within here, so it's going to print out meow, but then I'm going to have count decrease. So there's different ways to do this. You could say count equals count minus 1. So it's getting itself. So in this case 10 minus 1 will be 9, and it'll be put into count. Another way to go about this, so let me comment this out, is you could say count minus minus. This is what we call a decrement operator. And what it'll do is it'll just decrease the integer by 1. So there's another one where it's a plus plus where it increase it by 1, but this one it'll just keep on minusing it by 1. So kind of like what we have here. So there's a whole operator in Java for that. So now every time it decreases, it'll get closer to 0. And once it becomes 0, once it's false, then the flow of control will continue on. So it won't execute, again, just like with the if statement, if it's false, it won't execute what's in those parentheses. So then it'll go ahead and continue with the rest of the program. So if I run this, we should see about 10 meows display. So let's go ahead and run. There we go, and you see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 meows. And then it stops. This is the end of the program. If you want to see exactly what's going on, let's format this to where, let's print out the numbers. So you could print out count. So remember, you could print out the integers, and let's just format it to where it looks like some kind of numbered list. So I'll put the dot inside of the quotations along with the space. So now you should see actually it working backwards. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. So let's run this. There we go. And you could see that count is decreasing along with the while loop. So you'll notice this does need some thinking to go through, especially if you want something done a certain amount of times for a while loop. Again, it only checks if this is true or false. If you accidentally don't do this decrement, so you don't update your counter, it will go on infinitely. That's what we call an infinite loop, and that may not be good on your program. If that ever does happen, what you could do is you could right click in your console and you could say terminate disconnect all. And that would be your best possible solution for if you ever accidentally come across an infinite loop, and you will notice it sometimes even when it comes to Eclipse IDE, it'll stop it from doing too much. So just keep that in mind. Now another thing we're going to do, and do note I added in the scanner up here, so remember our scanner class, this is how we get an input. So let me actually go ahead and do that. Let me use inputs in this case. So actually we're going to start out with, so instead of count, or actually let's do a whole separate thing. So let's comment this out, and we're going to set up a while loop again. Only this time we're going to use, so let's do some kind of int, and I'm going to call this choice. Let's set this to 0 for now. And we're going to say as long as choice does not equal 3. So if choice is 0 right now, 0 does not equal 3, which is actually a true statement. So you do have to think about that logic. If 0 does not equal 3, then that makes this statement true. So we'll go ahead and do whatever's within this while loop. So in here, I'm going to say, I'm going to give some kind of output so we could actually see that it's still running. So I'm going to say here, type 3 to stop. Okay. And you'll notice, unlike the count, there isn't really any way, I mean, you could have it increase to 3, but actually that's not the point of what I want in this program. What I want is every time the user inputs a number, it'll keep on typing unless we type 3. So we're going to do choice equals std in. Remember, that's my scanner. And this is going to be scan, actually not scan, next int. There we go. So now this will keep on going unless I type in 3. So once I type in 3, then our variable is updated. And then here, if it says 3 does not equal 3, that comes out as actually false, and then it'll stop this input. So let's go ahead and run this. And you see it's waiting for my input. This is the first iteration of our loop. So if I type in 1, you see it ask me again, type 3 to stop. So let me type in 2, you see it's still asking me, so let's say 10, even -1, and it isn't until I type in 3 that it ends the program. It's not asking for my input anymore. I'm trying to type, it's not taking it in, and it reaches the end of the program. So this is actually what we call a sentinel stop. Basically, depending on a very specific condition, so in this case a certain number, then the loop will stop. Sometimes, actually most times, programmers use -1. So type -1 to stop, because -1, if you're working with mostly positives, -1 is not going to appear, so it'd go ahead and do that. So there we go. So if I type in 3, you notice it still continues. So 2, 5, but if I type in -1, it ends the program. So that's what we call a sentinel stop, or a very specific number, typically outside of your data range. Okay. So that's a while loop, and I'll keep this commented out for now, but we'll return to something like this later on. Okay, now another loop, for instance, trying to do a loop where with a certain amount of numbers with a while loop is, as you can see, a little bit trickier to handle. You do have to make sure that you're going ahead and updating the counter. Typically, while loops are used for something like this. So this example where you're asking a user input many times, looping through unless they type in something to stop. That's what a while loop is used for. Typically use while loops for moments where you don't know when the program's going to stop. So you'll use a while loop. So while this thing is true. So while loops are for uncertain amounts of times, something to loop an uncertain amount of times. But another type of loop, let me go ahead or I'll just directly type it. This is going to be called a for loop. So it starts out, again, we have the for parentheses and braces, and basically this one will do the same functionality as this version of the while loop. For loops are meant for a certain amount of times in which instructions will be repeated. So how this goes is, within these parentheses, it's not just going to be a conditional statement. Actually, there's going to be a lot more to it. So there's 3 separate parts. You have your what we call an initialization. Then you have your conditional. And then you have, some people call it an updater, but whatever's going to update that counter. So all of that's going to be within these parentheses, and they will be separated by semicolons. So let me actually indicate that up here. Okay, so in your initialization, you'll indicate a specific variable just made for this loop. So it's not going to be used anywhere else in the program. It's just for this loop, and it is used to keep count. So typically you'll see Java programmers say int I. So you'll see I a lot. And in this case, let's start at 0. So int I equals 0. So now I is only going to be used within these braces. So it's only used for the for loop. So that's your initialization, so your initializer. Then in your conditional statement, it works just like how we do for the while loops. In this case, we're going to say as long as I is less than, let's say, 20. So what we're going to do is we're going to go up from 0 and count up to 20. So that's what we're going to do. So that's your conditional, and notice I'm separating these by semicolons. That is necessary for your for loop. And now over here will be your updater. So basically, are we incrementing it? Are we decrementing it? Since we're trying to get from 0 to 20, you want to increase it. So we could do I++. If you want to go by 2s, there is a way in which you could do that. You could say I plus equals 2, which that would be the equivalent of here, I equals I plus 2. And so that would be the equivalent. You could use this assignment operator, which will do that instant math and assign it to I. But for now, we just want it to go up by 1. So since we're going to count from 0 to 20, so just do I++, and that will be your updater. There we go. And now we just have it do whatever instructions we want for each iteration. So in this case, we just want to print it out. So let me get my system.out.println line, and I'm just going to have I print out. There we go. So now if I click run, you'll notice it starts at 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. These are all the iterations that the for loop is going through, and it goes up to 19. If you want it to say 20, you have to indicate equal or less than or equal to. There we go. And you see it does the 20. So the type of operation you do up here does matter for your conditionals. So know your differences between less than, greater than, less than or equal to, or greater than or equal to. And also you have your equals and your not. Okay. If you want to, let's say in this case, you wanted to start at 1, just change that updater. There we go. So that would be counting up with for loops. And you could even do a lot more here. So let's say you only want to, if you only want to do the numbers that are divisible by 2, so that would be all of your even numbers, 2, 4, 6, 8. You may say, okay, well, we could do equal then, or here we could update it by 2s, which kind of can do the trick, especially if you set this to 0. So let's run that. There we go. You see I did plus equal 2. So again, that's the same as I equals I plus 2. There we go. Or another way to go about that, so we're still doing this plus plus, is you could check first. So remember how I mentioned in these braces you could still do if statements and even other loops. We're going to put an if statement in here. So for this amount of times, let's do an if statement. So if in this case, I'm actually going to say, here, we're going to use a combination of math and logic. There's different ways in which you could do this. So thinking critically, if we want to do something, if we only want to print even numbers out, so stuff divisible by 2, again, there's several ways. We could say, all right, so let's do, in this case, we would have to actually do modulus. Now, if you don't know what modulus is, let's go over here and take a look. Okay, let's erase this. So if you do a number, so let's say in this case 4, and the modulus operator is actually a percentage sign, so 4 modulus 2. What this will do is it'll do the division. So in this case, 4 divided by 2 goes straight into 2. But whatever the remainder is what's going to be the answer. So in this case, since we have no remainder, 4 modulus 2 is 0. So if I do 5 modulus 2, let's do the math this way. so kind of the long division style. So if we start doing this, 2, 5, so this would be 2. 2 times 2 is 4. There we go. And subtract that, that would be 10. And if you keep on going on, you would get that it's 2.5. However, we have this remainder, and that's going to be the answer over here. So 5 modulus 2 is 1. So you can mess around with that. So this is a mathematical operation, and we're going to go ahead and use it where we're going to say int. We're just going to say rem as remainder, and we're going to say I modulus 2. So if rem is equal to 0, so that means it directly divides, so it properly divides, there's no decimals, then you'll go ahead and print out. So let's get this and print out the number. If not, you'll skip over it. So this is still going to go through 0 to, in this case, 20, but it's going to skip over all of these numbers in between. So let's run this. There we go. So now you see it does 0, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So there are ways in which you could indicate that with for loops. It's not to just print everything out. You could check the condition in this case of your current count. All right, so that's one way in which you could use a for loop. Another way, let's go ahead and I'm gonna erase the code within here. So I'm gonna start erasing some things so we could work with this. Or actually, let's leave it be. We will leave this be just in case I ever want to share this code with you guys in the future. And let's set up our for loop again. So let's set up another for loop. Okay, so you have your parentheses, your braces, and then here our initializer. So int I equals, or actually notice here. So let me do this. And note, this is angry because we haven't done anything within here yet, but notice that int I does not interfere with int I down here because, again, it can only be used within the bounds of this for loop, and this I can only be used within these bounds. If I try to use I out here, it will not work because it's only declared within. So just keep that in mind. Okay. So let's do another I. Let's say our condition is that it has to be less than 10, and we're going to do I++. Okay. And let's go ahead here. Let's print out this, but I'm not going to do here, I'm just going to do a print, and we're going to have spaces in between. So concatenate with your plus, and then do your quotations with a space in between. So this will go ahead. Let me actually have this be 1. There we go. Oop. And if I want to go up to 10, let's do this. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Do note that this is still appearing on the same line because we just did print. So to fix that, I'm going to use our escape character. So again, -n, that's for paragraph break. So if we go ahead, or line break, there we go. And then that corrects it. So that's some formatting for you. But in this case, maybe we have this going on. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all in the same line. Now, if for whatever reason we want to repeat that, but maybe we want it to somehow do it by some weird multiplication. So maybe we want multiple lines with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and next one will instead be like, so these numbers multiplied by 2. So you can think of it as us doing some kind of weird timetables, but for these. So in this case, maybe this row will be here. So we're gonna say this one is times 1. Or in this case, we're going to say times I. Now you'll notice that if I run this, it'll keep on doing the times I over and over, times 2 times 3, but what we want it is here. Let me go ahead and type it up here. So my vision is, okay, so it's going to be times 1, and it'll do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But down here, maybe I want it times 2. So those numbers, but multiplied by 2. So then now you have 2, 4, 6, 8, 10, 12, and in this case it's 14, 16, 18, 20. And then so on with times 3. So I want that pattern occurring, but you'll notice it's kind of hard to do it with for loops. So we could actually have this work towards our advantage, and that would be something called a nested loop. So here, this is how we're going to do it. This may actually be a little bit trickier, but we'll work with it. So in this case, if we're going to keep on multiplying up to, let's at least do it up to, so dot 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 up to 5. So I'm going to have this go up to I is greater than, less than or equal to 5. Now if I wanted print all of these out, I could either do it directly or I could have a for loop do it for me. So we're going to do another for loop, but in this case we need something different from the variable I. So we're actually going to do int j. You'll see this kind of pattern repeatedly. J, and j is going to be less than or equal to, in our case we wanted it to go up to the 10th digit, so 10. And then you're going to do j plus plus. So do remember what variable you're working with for each loop. So j, and then you have to update everything along with j within this loop, and I is dedicated to everything contained in here. So now I could just go ahead, so we're just going to print, and it's going to be whatever j is times your current I. So if you kind of do this in your head, the first iteration I is going to be 1. So every time, so it's going to print out the times 1. Then it's going to be in this for loop, and this for loop is going to happen within this loop while I is still equal to 1. So in this case, 1 times 1 is 1, 2 times 2 is 2, so on up until 10 times 1. And then once it's done with this loop, we'll exit out, then go back to the for loop, increment I, so that will be now 2. 2 is less than 5, so that is true. So we'll go ahead now times 2, and in this case, j is going to reset. So remember, j doesn't exist outside, so here it's brought up into existence again. So j is equal to 1, and it'll go up to 10, so 10 iterations. But now since I is equal to 2, then it's going to be 2 times 1, 2 times 2, and so on. So if I run this, there we go. And oh, it does a little bit of a weird thing. That's because I haven't done the print line properly. So let's go ahead and do that. Let me do here. So that part's our line break. So now if I run it, perfect, much better. And oh, my bad, it doesn't have a space. We do want that space. And let's do the parentheses around here. Remember, this will say calculate this, and whatever the answer is, then we'll connect it. So now if we run this, much better. Now you could see kind of a timetables going on, or at least a weird version of timetables where it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then those numbers multiplied by 2, those numbers multiplied by 3, and those numbers multiplied by 4, and so on. So that's a nested loop, and that's kind of how you can help yourself with some parts of programs. In some cases, people use these. We'll talk about arrays later on, but if you want to access arrays, this is what you would be using. But do know anything from if-else statements to loops, you can have them within each other. But like something like this, you're going to need to keep track of it. and of where variables exist. So those are called our variables ranges where they exist. So note, I can't have I print out here. So if I try to print out I, Java won't let me because it doesn't exist outside of this space. Only within here. And if I try to do J within here or outside of this for loop, it also doesn't exist because it only occurs within here. So just take note of those different ranges. All right. So I will leave it at that for now, especially when it comes to the nested loop parts. That's a lot more of a extra that you could work around with. For your specific assignment where you're taking in user input and you have to track based on different answers, I will tell you, you're going to have to use a combination of this while loop that we used here, so to get some kind of user choice, and you're going to need some kind of if-else statement within that while loop. So you're going to have to keep track of that variable's value. Okay, but with that done, I'll leave it there. Again, if you need assistance, I have my student hours on Wednesdays. If you cannot meet those times, please send me a message to schedule a time in which we could go over these concepts. Because again, I am here to help you out, and I do want you guys to create these cool programs because we do get a lot into, we're really diving into the more, as you could see, interactive parts with Java. So if you are struggling, do not hesitate to reach out. I will find the time to help you out with this, either the assignment or even anything else you're curious with for the current topic. All right, thank you, and I will see you in the next video.